All right, now we are going to talk about the other kind of reflections, and these are horizontal reflections or are reflections over the y-axis. And what's interesting about these, and I apologize about this mess right here. When I titled it, I really don't know what I was thinking, but it wasn't really appropriate. So if you look at what's going on here, right? Going from this to this, right? So in the other ones, the negative sign is on the outside and it causes to flip it over the x-axis. But if you look at these examples are a little different and a little weird because if you really analyze this and you look at this, well, if you put the negative sign inside the parentheses and then you're squaring it effectively because it's a quadratic, what it does is it doesn't, it looks like it doesn't change it at all. And that's one of the weird things about these horizontal reflections is that you're going to look at this and you're going to be like, oh, well, it's kind of the same deal, right? So when it's squared, the graph is still going to move upward. All right, that's the thing about these horizontal reflections is that the graph still opens upward. It's just that it appears to turn on the y-axis, but a lot of times it's hard to tell that something's happening. You can tell, however, something's happening if you also have a translation with it. But for these examples, we're just going to kind of show you basically what happens. So if my parent function is this, and I say, okay, I want to find the graph of this, f of x, we'll say, we'll take an example from the last one, and we'll say 1/2 x, but we're going to make it negative 1/2, right? And we're squaring it. And so what I know from horizontal dilations, right, is that this is going to take my horizontal distance and it's going to change it, right? So if I think the best way to try and think about this is just think of what this would look like in a table, right? But then think about what this negative sign actually does. Okay, so if I put in 0, right, I got x, and then I got negative 1/2 x, and I'm taking this whole thing and I'm squaring it. Well, isn't that basically the same thing as just 1/4 x squared? And then pretty much that negative sign has gone away. You got your 1/4, and then it just looks like a straight up vertical dilation problem, right? We're going to wind up with something that's going to look sort of like this. It's going to be all crazy like that and small. So it's your values be 0 and 0. You put 1 in, you're going to get 1/4. You put 2 in, you're going to get 1. You put 3 in, you're going to get 9/4. And so you get something it looks like it's being flattened towards the x axis, right? And I believe we said that it was being compressed vertically was the language we use if we talk about it in this terms. But what's important to note is with these horizontal reflections, which is what this isn't a dilation we're talking about, even though it winds up looking like one. Because it's a reflection, it's important to note that as you go on later on and you do problems like this, when this changes to anything that's an odd number, that's when you're going to really see how this is actually reflected over the y-axis. But because it's quadratic and because it's even, and the laws of that on negative numbers, it doesn't really look like it changes anything. So another example would be if I took f of x and I said, okay, I'm going to change this. All right, let's call this g of x. I suppose I could erase that and make it look nice. If I have g of x and I say, okay, I'm going to make this into negative x squared. Well, pretty much that doesn't really change anything because that negative sign gets impacted by the squared sign and it just winds up being x squared. So you wind up with a graph, and I'll make this in orange, that's going to wind up being the exact same graph, but it appears to, it actually has been reflected, but because it's spinning on this thing right here, it's different. I think where you will see some things different is when you start looking at something that has a vertex that isn't on this axis, and then when you see it there, you're going to see some other weird things happen. But it's just good to know about this and good to be aware of this. You won't do a ton with this at this point, so you don't have to worry a lot about this, but just to be aware of how it is different from a vertical reflection. All right, thanks for watching.